Hello everyone, welcome back to Tanya Chu YouTube video. In this video, I am going to discuss Cambridge IGCSE Physics Paper 2 Multiple Choice or Extended Paper 2 with code 0625/21. And the paper that I'm going to discuss in this video is October-November 2024. So are you ready? Let us get started. Let us start with the first question itself. Number one, a student uses a mirror ruler to measure the length of a sheet of paper. Which measurement is shown to the nearest millimeter? First of all, this is a piece of paper right here. So whenever you use a meter ruler, you have to understand the sensitivity of the meter ruler. The sensitivity means the smallest division of that apparatus. So the smallest division of our meter ruler is actually 0.1 cm. So this is called sensitivity, which represents the smallest division, which is equal to 0.1 cm. But hey, I want you to see all the choices here, A, B, C, and D. All the choices are recorded in meter. So I have to round it off to meter. So we have to use a little bit of basic of math here. You definitely know that 1 cm is equal to 1 over 100 meter. Because you have to convert the cm to meter, which also equals to 0.01 meter. So not gonna convert 1 cm, but I'm gonna convert 0.1 cm to meter. So 0.1 cm to meter. So you just take the smallest division, 0.1. Let me erase this a little bit. You just take 0.1 multiplies by 0.01. There you go. So you get 0.001 meter. Now this part is very interesting. 0.001 meter. Whenever you do your measurement, you have to bear in mind that all the readings must be recorded according to the decimal points of the apparatus, the smallest division, according to the smallest division of the decimal points of that apparatus. In this case, our meter ruler, the sensitivity or the smallest division is 0.001 meter. So that is why your reading has to be in 3 decimal points. So 3 decimal points, B is the answer. Now, the second question, a rocket travels with an average speed of 6 kilometers per second for 2 minutes. What is the distance traveled by the rocket? Whenever you talk about a distance, you better write down, I would strongly suggest you to write down the equation for the average speed. Average speed is equal to total distance divided by total time. Average speed is given in 6 kilometers per second. Normally, I would change that kilometer to meter. But hey, before you do any changes, you have to look at the 4 choices that you're given here. All the 4 choices are given in kilometers, so you did not have to do any changes to that. So just put in 6. Total distance is the one that you have to find. Total distance. Time is in 2 minutes, but before that, I want you to look at the speed. Speed is measured in per second, kilometer per second, but the time is in minute. So you have to change that time to second. So it is 2 times 60 because 1 minute is equal to 60 seconds. Therefore, total distance equals 6 times 2 times 60. So your answer should be 720 kilometers. C is the answer. Now, question number 3. The diagram shows the vertical forces acting on a ball as it falls vertically through the air. Now, air. The ball does not reach terminal velocity. Now, what is terminal velocity again? Terminal velocity simply means that the maximum velocity achieved by an object, or in this case, the maximum velocity achieved by the ball when the resultant force acting on the ball is equal to 0. Or in other words, air resistance balances the weight of the ball. Now, the question did mention that the terminal velocity does not Yeah, it's not being reached. So which row describe what happens to the resultant force on the ball and what happens to the acceleration of the ball as it falls through the air. So before the resultant force is equal to 0 and before the air resistance offset the weight of the ball, the resultant force because the air resistance keeps on increasing due to the speed of the ball that is increasing when the ball is going towards the ground. So since the air resistance keeps on decreasing and the weight of the ball is constant because the ball is on the surface of the earth, therefore the gravitational force acting on the ball is constant. Now, due to air resistance, the outward force keeps on increasing, whereas the downward force is constant, gives you decreasing resultant force. And since F equals to ma, when the resultant force is decreasing, the acceleration must decrease as well. That is why the answer is A. Now, the next question, question number 4. A coconut falls from a palm tree. At X, oh, where is X? X is at the highest point. It has just started falling. Y is the point just before it hits the ground. What is the acceleration of a coconut at X? Air resistance can be ignored. Whenever I give you some tips here, whenever you see that the question did mention that the air resistance is being ignored, the only force that acts on any falling object will be gravitational force. And the gravitational force depends on gravitational field strength or depends on the gravitational acceleration, which is also constant. So that is why the answer is C. Because the gravitational acceleration at y is 9.8 meter per second square, and the gravitational acceleration at point x is also equal to 9.8 meter per second square. Now, number 5, a car is driven round a bend in the road at a constant speed. Whenever you see this word, I am going to highlight it for you. When you see constant speed and you see round a bend, right? There is only one resultant force that is acting on the car. The resultant force is called centripetal force. Centripetal force is not going to change the speed of the car. It's not going to make the car travel faster or slower, but it is going to control the direction of the car so that the car can have a smooth around the bend. Right? So smooth turning around the bend. So the direction of the centripetal force must always be directed towards the center of the circle or center inside, towards inside the bend. And since the centripetal force is not changing the speed of the car, that is why it cannot add parallel or anti-parallel to the car. It cannot add in the direction of the speed because when the force is acting in the direction of the speed, the car will move faster. So that is why the answer is C. Question number 6. The diagram shows a drawbridge that is attached to a wall by a hinge at one end and a cable at the other end. The weight of the drawbridge and the tension in the cable are represented by the labeled arrows in the diagram. There's a third force at the hinge. Okay, remember this? There's a third force at the hinge, which is not being shown. The drawbridge is in equilibrium. Now, this is a very important word here when they mention the forces are in equilibrium, right? So you have to be able to draw a close triangle. And the direction of the arrows must be follow each other and form a closed loop. So I am going to draw these two forces first. Could you see that? Weight is acting downwards. So I'm going to use tip to tail rule. So the tip of the tension is being followed. This is what we call tip to tail rule. The tip from the first force is being joined with the tail of the second force. And when this system is in equilibrium, so it has to be able to form a circle like this. Form a complete triangle. I'm sorry, not a circle, but a complete triangle. A closed triangle. And the arrows must follow each other in one direction. So the answer is D. Now, question number 7, which equation gives the momentum change of an object? I'm going to look into this one by one. Momentum change is equal to force per area. This is definitely wrong. Pressure is equal to force over area. So this is wrong. B, momentum change is equal to force multiplies by distance. Force multiplies by distance that move in the direction of force is called work. C, momentum change is equal to force times distance over time. That means force times speed, that is power. This equation is only valid when the object is moving at constant speed. To use the equation of power equal to Fv. D, momentum change is equal to force times time, which is also true. Force times time is also called impulse. Impulse represents the change in momentum. So D is the answer. Number 8, which statement about the use of nuclear fuel as an energy resource is correct? It obtains its energy from the sun. That is not true. B, it has no environmental impact. Wow, nuclear fuel, they are using radioactive sources, so of course it has environmental impact. So this is wrong. C, nuclear power stations do not need turbines. If you have no turbines, how are you going to generate electricity? Don't you think so? So this is wrong. D, the energy is released by nuclear fission. This is true. Nuclear fission means the explosion or the splitting of very, very big, unstable radioactive nuclei to form a smaller fragments and give out large amount of energies plus neutrons. Now, question number 9. The diagram shows an object of mass m being projected with speed v from a point P to a point Q on top of a cliff height h. The object does work W against air resistance as it travels from P to Q. What is the kinetic energy of the object when it reaches point Q? Now, when I see this type of question, whenever they talk about the energy, whenever they give the speed, whenever they say the object does work, this is actually the hint. Object does work against air resistance. That is the hint. I am going to use the principle of conservation of energy, states that the total initial energy has to deduct the work done against the friction or air resistance equals to the final energy. So now I have to look at point P. Point P, when the object is at point P, since there's no height, so the only energy that object has is the kinetic energy. So I'm going to put Ke minus work done against friction first. And when the object reaches point Q, right? So since the question did mention that what is the kinetic energy of the object when it reaches point Q, so object has kinetic energy plus gravitational potential energy due to the height. So kinetic energy is half mv squared. I'm using mv squared because the speed is given as v minus work done against friction, which is W, is equal to kinetic energy at point Q plus mgh. So all you need to do is just to rearrange the equation and make kinetic energy at point Q as the subject, which is equal to half mv squared minus W minus mgh. Is there any answer here? Yes, there is. The answer is D. Question number 10. The diagram shows the Sankey diagram for an electric drill. What is the total wasted energy shown by the diagram? Now, the usefulness of the Sankey diagram is to see how efficient an electrical appliance is. So with the energy input given and to see whether the energy is being wasted, right? So the wasted energy in electric drill, because electric drill, we want kinetic energy. So the wasted energy should be sound energy and thermal energy. We don't want any sound, but somehow it gives up the sound, right? And we don't want heat, but somehow it will give up the heat. So this one for sound, because they told you distance between two lines is 40 joules. This is 40 joules right here. 40 joules. And what about this? This one is 1, 2, 3, 4. 1 to 160 joules because 4 boxes times 40. So the total wasted energy is equal to sound energy, which is 40 joules plus 160 joules. That gives you 200 joules. B is the answer. Question number 11. An elephant of weight 45,000 newtons stands with all 4 feet on the floor. The average pressure on the floor due to the elephant foot in contact with it is 34,000 Pascal. So what is the area of each foot? 4 foot is 45,000. So I need to find the force of 1 foot. You get me? So 45,000 divided by 4, and I get 11,250 Newton. And since the pressure is being given, I just use pressure is equal to force over area. So 34,000 is equal to 11,250 divided by area. So you can do your cross multiplication, which area is equal to 11,250 divided by 34,000. And there you go, 0.33 meter square is the answer. So B is the answer. Question number 12. Some air is trapped inside the metal container with a tightly fitting lid. Tightly fitting lid means that the air particles could not escape to the surrounding because it is tightly fitting the metal container. So the container is heated strongly behind the safety screen. So just in case implosion occur. So the lid is blown off by the increased pressure of the air inside the container. Can you see how strong the air particles are? So what causes the increase in pressure of the air inside the container? First of all, the pressure. Of course, it will increase because pressure depends on force. Pressure is defined as force over area. Area of metal container is the same, but due to the force that is increasing. Force by what? The force actually is by the air particles that giving the force inside the metal container. And that force is being defined as the rate of change of momentum. So how do I get this? Because the air particles, when they are being heated, so they will collide more frequently with each other as well as the wall of the container. And the collision is elastic, right? Due to the high heat, the speed or the kinetic energy of the air particles is also high. So that is why the force increases. When the force increases, the pressure will also increase. So B is the answer. So remember that when anything that is being heated, the temperature will increase. When the temperature is related to kinetic energy, and the kinetic energy is related to speed. Now, question number 13. A very hot mug of coffee is near a large unheated swimming pool holding 2 times 10 to the power 6 kilogram of water. Which statement is correct? Right. Now, let us look at A. If the mug of coffee is tipped into the pool, the coffee will lose much more internal energy than the water in the pool gains. Sounds confusing a little bit, but no problem. We move on to B. Internal energy of a substance depends only on temperature. No, it doesn't depend on the temperature, but it is also depending on the specific heat capacity, depending on the mass as well. So B, I can confirm that this is wrong. See, the internal energy of the water in the pool is lower than the internal energy of the mug of the coffee. Now, when we talk about internal energy, I better give you the equation. The energy is equal to mc delta change in temperature. E represents internal energy, M represents the mass, and C represents the specific heat capacity, and delta T represents the change in temperature. Right, so I would say that even though the coffee, right, is of the higher temperature, so maybe the change of temperature in coffee is higher because the temperature would decrease when the mug of the coffee falls into the swimming pool. Right. So because the heat would transfer out from the coffee to the water in the swimming pool. So that is why the change in temperature until the water in the swimming pool has the same temperature as the water or as the temperature of the coffee. So the change in temperature might be higher for the coffee, but the mass of the coffee as compared to the mass of the water in the swimming pool is way, 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 right, 2 liter because the mass of the water in the swimming pool is 2 times 10 to the power of 6. The mass of the coffee is not even 1 kilogram because that is a mug of the coffee. It's just lesser than that. So that is why internal energy of the water is not lower. It is actually higher because the mass of the water is higher. So C is wrong. D, when the temperature of the mug of coffee falls, its internal energy will decrease. So when the temperature falls, the internal energy will also decrease. That is definitely correct. Therefore, the answer is D. Now, if you have any comment, do not hesitate. Just comment below. And let us start with question number 4 now. A student measures the mass of the water in an open container over 2 hours. The container is kept in warm room. The results are in the table. Why does the mass of the water change? Okay, now let me see. It seems that the mass of the water is decreasing. When the mass is decreasing, the answer is definitely because the water evaporates. Don't you think so? Right? To the open air. That is why, because the room itself is warm, it causes the rate of evaporation to increase. Now, question number 15. A 1 kilogram block of aluminium requires more thermal energy to raise its temperature by 1 degree Celsius than 1 kilogram block of copper requires. Why is this? Now, write down the equation first. It will confuse. E equal to mc delta T. So 1 kilogram requires more, okay, this is aluminium, requires more thermal energy to raise 1 kilogram, right? M delta T. More energy is due to higher specific heat capacity. So aluminium has higher specific heat capacity than copper. The definition of specific heat capacity is the energy that needed for a substance to increase its temperature, right, by 1 degree Celsius. So that is why. C is the answer. Now, question number 16. A block of ice is at a temperature of negative 100 degrees Celsius. Energy is supplied at a constant rate. The graph shows how its temperature changes. At which points have the ice completely changed state to water and all the water completely changed state to steam. At this point, could you see that the melting point of the ice occur at 0 degrees Celsius? So completely change to water has to be 2 because at 1 it started to change to water. So 2 is the answer. Completely change to steam at 100 degrees Celsius. Could you see that? Right. So at point 3, it started to change to steam. So that is why the answer is D. Question number 17. Water waves are reflected at a plane surface. Which property of the waves is changed by the reflection? Reflection, it will cause the direction to change because it occurs in the opposite direction. Everything else will remain constant. Question number 18. A light ray is passed through air, glass, and water. At which point does the light speed decreases? Light speed will decrease when it travels from air to a medium. So it started to decrease at W because travel from air to glass, and it will start to decrease at Y because it traveled from air to water. So W and Y is the answer. Now, question number 19. Plain water waves approach a narrow gap. Narrow gap is the hint in a barrier. Which diagram shows the diffraction pattern that would occur? So the answer for diffraction is that no change in the wavelength. B cannot be the answer because there's no change in the wavelength. It seems that wavelength increases after diffraction. B and D are wrong. So what about A and C? Seems to be more accurate because diffraction means spreading of the wave. Wave have to spread out in all directions after passing through that small gap. C is the answer. Question number 20. A ray of light enters a transparent plastic wedge from air and is incident on a lower surface at the critical angle. Now let me explain what is critical angle. Critical angle is the angle of incident when a light ray travel from a denser. So you have to check first where's the direction of travel of the light ray. The light ray has to travel from denser medium to less dense medium. And the incident angle which causes the light ray to be refracted at 90 degrees. Right? So now the angle of incidence is I, the angle of refraction is R, and the critical angle is C. In which ray diagram are the angles labeled correctly? Now let me see. This is correct. Angle of incidence, angle of refraction. But hey, critical angle must be measured from the incident ray and normal. Critical angle should be here, so A is wrong. Now let us look at B. Incident angle is correct. Refracted angle is correct. Wow, critical angle that causes the light ray to be refracted at 90 degrees. That is absolutely correct. C is wrong because I is supposed to be here, R is supposed to be here. D is also wrong because I is supposed to be here and C is supposed to be here. Now, question number 21. An object is placed 20 cm in front of a thin converging lens. The scale diagram shows how the lens forms a real inverted image. Which row gives the focal length of the lens and the distance of the image from the lens? Now, focal length, because, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 represents 5 cm. Focal length is the distance between the center of the lens to its principal focus. So I want you to pay special attention to ray number 1, the one that I highlighted here. Any ray that is horizontal, coming from object before passing through the lens, the ray is horizontal, would be refracted at principal focus. So this is actually principal focus right here. This is called principal focus. So the distance between the center of the lens, I am going to use a different highlighter so that you can see it. From the center of the lens to the principal focus, that is what we call as focal length. So focal length seems to be lesser than 5 cm, so I will take 4 cm. And the distance between the image and from the lens has to be measured from the center to where the image is being formed. So 10 small boxes, which represents 5 cm. Therefore, A is the answer. Number 22, radio waves are electromagnetic waves. What is the wavelength of radio wave of frequency 2 times 10 to the power of 5 hertz? Whenever you want to find a wavelength, just recall the equation of the waves. Wave speed is equal to frequency times the wavelength. So radio waves are electromagnetic waves, and all the electromagnetic waves travel with the speed of light, which is 3 times 10 to the power 8. And the frequency is given as 2 times 10 to the power 5, lambda. So you make lambda as the subject. 3 times 10 to the power 8 divided by 2 times 10 to the power 5. And the answer is 1500 meter, 1500 meters. That's the answer. 23. A candle flame is placed in front of a loudspeaker. The loudspeaker produces a sound wave that causes air particles to vibrate. The vibrating air particles make the candle flame vibrate in the same direction as the air particles. Which row shows the direction of vibration of the candle flame and the nature of sound wave? Sound wave has to be longitudinal wave. And the direction of travel is parallel to the direction of propagation of the particles, propagation of the energy. The direction of the vibration of the particles will be parallel. So that means to and fro, and the energy will be transferred forward. Question number 24. The diagram shows a part of the magnetic field around a strong magnet. In which position does the magnetic pole experience the strongest force? The strongest force, all you need to do, because the magnetic fields are being drawn for you, all the distance between the magnetic field will be the closest one. That will give you the strongest force. A is the answer. Quite obvious, don't you think so? Number 25, there is a current of 0.6 ampere in a closed circuit. How much charge passes a point in the circuit in 2.5 minutes? Charge, kill it! So that's the charge. Current is 0.6 ampere, but time has to be in seconds. So you have to take 2.5 minutes, change to second. So the answer is 90 coulomb. C is the answer. Now we continue with question number 26. Which two physical quantities have the unit joule per coulomb? Wow, joule per coulomb. I have to do it one by one. Charge is measured in coulomb, energy is measured in joules. So for A, right, the charge is measured in coulomb, and then the energy is in joules. So it doesn't give you the quantities that have the unit of joule per coulomb. Now, charge is coulomb, potential difference is volt. So there is no joule per coulomb as well. But, oh, okay, I need to do this definition for these two quantities because if I compare in this way, then I wouldn't be able to get the answer. So let me erase this one. Okay, charge is charge. Okay, charge is defined as current times time, so the coulomb. Energy is defined in joules. B, charge is defined in coulomb. Potential difference. Okay, now let us look at potential difference. It is being defined as work done in moving a charge from one point to another point. So work is in joules and the charge is in coulomb. So joule per coulomb for potential difference, but not for charge because the unit of charge is coulomb. C, electromotive force is measured in volt as well. So it can take the unit of joule per coulomb, same as potential difference. So C is the answer. Question number 27. A copper wire is placed in an electrical circuit and its resistance is measured. The wire is then replaced with a second copper wire with twice the length and a quarter of diameter. Now. So I have to write down the relationship between resistance and the other quantity. Resistance is directly proportional to length, and resistance is inversely proportional to cross-sectional area. But the problem is cross-sectional area is not being given. So I have to change that cross-sectional area of the copper wire, which is the circle, cross-sectional area of the circle, to pi r squared. But God, you know that there's no apparatus in the lab that we can use to measure the diameter of the wire. So that is why diameter needs to be related to, the radius needs to be related to diameter. So I replace the radius with diameter. So pi d over 2, you square the whole thing, you get the surface area of the wire, cross-sectional area of the wire is pi d squared over 4. And now I am going to come up with the general equation for the resistance. So resistance is directly proportional to length, but inversely proportional to pi d squared over 4. And then make this more complete. I get rid of the proportionality symbol by putting a constant here, length over pi d squared over 4. I am definitely going to use this to do my calculation. So I'm going to write now on the left-hand side, if you don't mind. So resistance of the first wire. Can I do it right here? Okay, never mind. I just do it here. So resistance of the first copper wire first is given as R, copper wire, and the length, I just put KL over pi d squared over 4. That is the first one. And the second copper wire, the resistance R2, I just put it as R2, R1 and R2. K, the length is twice the length, but the diameter is 1 over 4. D, you have to square it over 4. So I make this, simplify this a little bit. 2 length over pi 0.25. Okay, 1 over 4, 1 over 4. You square it, okay, you get 1 over 16. I just put 1 over 16 right here. D squared over 4. Wow, sounds complicated. Right, so now I am going to solve these two simultaneous equation. I'm doing on the right hand side. I take equation 2 divided by equation 1. So R1 divided by R2. It is R2 divided by R1 seems to be easier. So I put R2 divided by R1. R it's just okay. R1 divided by R2 will do as well. KL over pi d squared over 4. This is division, so I straight away inverted it by multiplying it. Pi 1 over, this is 1 over 4. The d squared here. Okay, the whole thing 1 over 4 has to be squared. So this is 4 squared, you get divided by 1 over 16. So 1 over 16 d squared over 1 over 4. Okay, now let me do it. Okay, over 4 right here. and divided by K times 2L. Now, my favorite part is here. I love to cancel. KL, KL. Pi d squared over 4, pi d squared over 4. Could you see that? So R1 divided by R2 is equal to 1 over 16 divided by 1 over 2. So you get 1 over 32. So 1 to 32. So D is the answer. Now, question number 28. If you have any hesitation or whatsoever regarding this question, do not hesitate to ask. Right? You could take your time to pause the video to see how I solve it. Now, question number 28. Which circuit contains a diode connected in series with a fixed resistor? Look at A. A, this is called LDR, light dependent resistor. So I want a diode, so A cannot be your answer. B, this is a variable resistor. Variable resistor is used to change the resistance to control the amount of current, as well as the other one is thermistor. So I want a diode and a fixed resistor, so B cannot be the answer. C, a fixed resistor and a diode sounds correct to me. D is wrong because D, this is a variable resistor and a diode. So C is the answer. Question number 29. In the circuit shown, resistor X has twice the resistance of Y. So resistance X is 2R, resistance Y is R. Just write it down. Which statement about the circuit is correct? So the current in the cell is greater than the current in the X, which is true because the total current is coming out from the cell that will split out to X and Y. Before splitting out, the current must be the largest current coming out from the cell, which is true. But let us look at B. The current in X is greater than the current in Y? No, no, no. Current is like us human. Resistance means risk. If you know that there is a double the risk, will you ever take the risk? Oh, if you are the risk taker, that is not valid to you. But coward like me, I would not take the risk. So I would say that current will choose the shortcut, easier way to flow. So current in Y is greater than the current in X. Remember that. See, the potential difference across the cell is greater than the potential difference across X. How can it be? Potential difference across the cell is the same as potential difference across X and Y because X and Y are connected in parallel to the cell. So this is same. D, the PD across X is greater than the PD across Y. No, because X and Y are being connected in parallel circuits. So the PD must be the same. A is the answer. Now, question number 30. A 4 ohm resistor and an 8 ohm resistor are connected in series with a power supply. Now, let me draw it out. This is 4 ohm and this is 8 ohm. They are connected in series with a power supply. Doesn't matter. A voltmeter is connected across the 8 ohm. Okay. And this voltmeter reads 36 volt. What is the voltmeter reading when it is connected across 4 ohm? So now this is a diagram that I drew. First thing, I'm going to find the current that passing through the 8 ohm first. I'm going to use Ohm's law, V equals IR. So V is 36, I times the R, 8. The current that flowing through the 8 ohm resistor is 36 divided by 8, which is 4.5 ampere. It is the same current that flowing through the 4 ohm. Why? Because 4 ohm and 8 ohm are being connected in series. Therefore, I'm going to use V equal to IR, V across 4 ohm, right? So V across 4 ohm is equal to I times the resistance, which is 4. Therefore, you get 18 volt is the answer. B is the answer. Number 31, a metal rod XY is placed in the magnetic field so that it is perpendicular to the field as shown. In which direction is the rod moved so that there is an induced current flowing from Y to X? I want the induced current to flow. When you see the word induce, straight away use Fleming's right-hand rule. So they mentioned that magnetic field, this is first finger, represents the direction of magnetic field, just move to the right, and the direction of the induced current must flow upwards. Could you see that? My thumb seems to be pointing at me. That is why the force must be out of the paper towards the observer. D is the answer. Question number 32. The diagram shows a basic electric motor. What are the names of the features? X, let us look at X. X is being called coil. So coil, the answer is quite obvious. Y is being called carbon brushes. Carbon brushes are used to add as circuit completer to complete the main circuit, power supply, and the coil. And Z is being called split ring commutator. B is the answer. Question number 33. This is quite confusing. Two transformers, P and Q, each have 2,000 turns. Right now, I'm going to draw it, P and Q. Two transformer. This is transformer P right here. And this is transformer Q right here. I'm going to draw it up. Okay, now let me write it down. This is P, this is Q. And each have 2,000 turns. 2,000 on their primary coil, and 1,000 on the secondary coil. 1,000, and this is also 1,000 on the secondary coil. Secondary of transformer P is being connected to primary. You see that? And then of transformer Q. So P is the one that is being connected to AC supply. And then, okay, I write down all the necessary information here. Q provides a motor. This is motor of 0.2 ampere. What is the current being supplied to the primary of transformer P? I want this current. So since the transformer is 100% efficient, so you can write down, I calculate for Q first. P input is equal to P output. P input is equal to I input, V input of Q is equal to I output, V output, or I secondary. Now, since the, what is that? The number of turns is being given. So I need to find the output, okay, for Q, right? The output current is 0.2, but I don't know the secondary current. I don't know the primary current, and I cannot find the input current to Q. So I need to find, okay, a relationship. I input to Q is equal to 0.2 times Vs, primary voltage, secondary voltage per primary voltage. Don't worry because number of turns are being given. So I find number of turns in the secondary coil divided by number of turns in the primary coil is equal to secondary voltage per primary voltage. So number of turns in the secondary is 1,000 divided by 2,000, which is equal to Vs over Vp. So Vs over Vp is given as 0.5. So the ratio is 0.5. So I'm going to use that ratio and sub in here. So I input to Q is 0.2 times 0.5. That gives you 0.1 ampere to Q. So it also means that the I secondary coming out from P, it also means that I secondary coming out from P is 0.1 ampere. So I'm going to write it down. Okay, so this I is 0.1 ampere. Now let me do my calculation for P. I primary, V primary is equal to I secondary, V secondary. So I primary is the one that I have to find. And then, okay, I secondary, Vs over Vp. So I primary from P is I secondary, which is 0.1 times the ratio, the secondary voltage to the primary voltage, 0.1 times 0.5, you have 0.05 ampere. So the answer is 0.05 ampere, which is D. Question 34. Alpha particles are directed at the metal foil. Most of the particles pass through the foil with little change in direction. A small proportion of the particles are scattered back through the large angles. What does this evidence suggest about the structure of an atom? So let us see. It consists of a charge center, much smaller than the size of the atom. This is correct. With little of the mass. No, with most of the mass of the atom. This is wrong. B, it consists of a negative charge. No, that is wrong. It consists of a charge center much smaller than the size of the atom, but most of the mass of the atom. It sounds correct. Let us look at D. It consists of a positive charge, the size of the atom containing small negative. No, there are no small negative charges scattered through it. C is the answer. Number 35, which statement correctly compares the properties of alpha particles and beta particles? Alpha particles are helium nucleus, which is positively charged. Beta particles are fast-moving electron, which is negatively charged, -1. Right. Alpha particles are less penetrating than beta particles because alpha particles are less ionizing. No, penetrating power are opposite. Penetrating power is actually opposite to ionizing power. So alpha has the most ionizing power. B, alpha particles are less penetrating than beta particles because alpha particles are more ionizing. This is correct. Alpha particles are more known. Alpha particles are less penetrating because alpha particles are big particles. They cannot penetrate through a lot of stuff. Now, question number 36. Which statement about alpha decay is correct? Alpha decay for 2Ha. So the nucleus loses electrons. Now, the nucleus changes to that of a different element because you decay, right? The proton number will change. The nuclear number will also change, right? B is the answer. C, the nucleus does not decay until one half-life. That is not true as well. D, after two half-lives, alpha decay always stop. No, not necessarily stopping. Number 37, an explosion in a nuclear reactor spreads the isotope cesium-137 across a large area. After 90 years have passed, the quantity of caesium present is 12.5% of its original level. What is the half-life of the cesium? So you know what? I don't know whether you are more comfortable using equations or the formula, but I'm going to use the table form to do it because it is more understandable. Right, so initially it has 100%, right? So this is when time equal to 0. So when it decays to half of its original value, which is equal to 50%, that is called one half-life. When it decays again to half of 50%, that is 25%, that is already two half-life right here. And keeps on decaying again, that is 12.5%. This is three half-life. Three half-life is given as 90 years. So I put 3 half-life is equal to 90 years. Half-life is equal to 90 divided by 3. So half-life is 30 years. C is the answer. Now, question 38. Which type of object rotates around the sun with an elliptical orbit? The answer is A, planet. Number 39. Which statement about the sun is correct? A, the nuclear reaction in the sun create mainly radio waves and microwaves. No, no radio waves. B, the sun is powered by fission reactions in which no, that is not fission, nothing to do with fission. Fission occur in nuclear reactor. So D, the sun is powered by fusion reactions and electromagnetic radiation is produced. D is the answer. 40. The last question. To determine the value of the Hubble constant, an astronomer measures the distance of a galaxy from Earth as 2.5 times 10 to the power 21 kilometer. She also measures the speed of recession of the galaxy. Recession means the speed of galaxies getting away from the Earth as 5.2 times 10 to the power 3 kilometer per second. From these data, what is the value of the Hubble constant? D is being given. Distance is 2.5 times 10 to the power 21 kilometer. And then the speed is also given, which is 5.2 times 10 to the power 3 kilometer per second. So you know that Hubble constant is speed over distance. So speed is 5.2 times 10 to the power 3. Distance is 2.5 times 10 to the power 21. I am not going to change the kilometer to meter because both have kilometer. So I divide it, I get 2.08 times 10 to the power -18 per second. B is the answer. So thank you very much, guys, for watching. Right? Please subscribe to my YouTube channel for more tips and tricks as the exam is approaching. And do also comment below if you have any of the topics that you feel doubtful and you want me to discuss it on YouTube. And any past questions that you have problem with, just bust me out. Thank you very much for watching, and I will see you again in my next video. Bye.